Okay, Unit 15, Lesson 3 is box and whisker plots. So you can call them box plots, but the technical name is box and whisker because you'll have a box in the middle and then two whiskers on the end. And notice the idea is not that the box is the same size, the whiskers are the same size. This talks about the spread of data, so you want to calculate it exactly and represent it. Okay? So there are 5 data points that are important. So we'll go in order. So the minimum value is the lowest value in your set of data. And then next we call it quarter 1, which is the lower quartile. So this represents 25% of the data. Okay, and then in the middle we have the median. And notice that's the middle of your box. That represents 50% of your data. And then the end of the box is called the upper quartile. So that's called quarter 3. And that's 75% of your data values. And then at the end of your whisker, that is your maximum. Okay? Which is always your highest value. And so all box and whisker plots, you plot the 5 points and then you connect them in that manner. All right, so the interquartile range is when you do the quarter 3 minus your quarter 1. So it actually is the range of the box. Okay, so these are pretty easy to calculate. There are computer programs that if you enter your data on a graphing calculator, it will do it. But honestly, it's pretty easy to do it by hand. So that's what we're going to do. So let's look. I've got 2 examples. So on our first example, you always want to put the data values in order. Okay, that is the key. So we're just going to go ahead and do that. So let's see. We've got 11. 12. And if they repeat, you do want to repeat them. It looks like 15, 15. Leave a little space. We've got 16. Looks like 20, 21, 23, 29, and 30 and 30. So next, you're going to count the number of data values. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I have 11. So we need to find, I always find my middle first. Now, if it doesn't happen to be, we want to split it into 2 equal groups. If it doesn't happen to be equally, you'll just want to at least divide it. So if I've got 11 data values, that means I need 5 on each side. So 1, 2, 3, 4, 5. And that means I've got 5 on the right. So I actually have a value in my median. So that's my median. So then I'm going to find the middle of each set. So in the bottom, if I've got 1, 2, 3, 4, 5 values, I need to split that in half. So the third value is going to be my middle. 1, 2, 3. Okay. And then we know our max and min. So min and max. So because we had an odd number of data values, we actually were able to use data values given as those 5 values that we need. All right, because it's odd. So odd number of data, you're going to use the values given. But always split it in half, split it in half, split it in half. So now we're going to plot those. So at 11, and notice I have a number line already marked, otherwise you'll make your own. I'm just going to put my 5 dots. Quartile 1 is at 15, 20, 29, and then 30. So I draw my 2 whiskers, and then I draw my box. Now, you technically don't need to label anything because this is a pretty clear graph. If you couldn't tell what those values are, you're welcome to just write them above. But you technically do not need to do this. Okay? All right. So let's do example 2. So these are list of BYU points in the 2009 football season. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I'm going to actually skip this. So let's take this one off, okay? Because I want an even number. So let's take that one off. All right, so I'm going to put them in order. So I've got 7, 14, sometimes it takes me a while, 24, 26, 28, looks like 30, yep, 35, looks like 38 twice, 42, 52, 54, and 59. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so I have 12 values. I wanted an even number. So with 12 values, I first need to split them into 2 equal groups. So they both need 6. So 1, 2, 3, 4, 5, 6. So notice there's not a number in the middle. So we're going to have to find that. And then I'm going to split this in half. 1, 2, 3. If there's 6, that means I need 3 in each group. And notice there's not a number there and 3 in this group. Okay, so I still have my min, we still have our max, but my other 3 dots are where these lines are. So I can tell between 24 and 26, that's 25. Between 42 and 52, well, that's 10 apart, so if I add 5, but if you're not sure, you take the average. Okay, so, and then same thing here, if you didn't know it was in the middle, you can have decimals. You'll take the average of that. So if they're 3 apart, that means I need to go 1.5, so 36.5. Okay? And those are my 5 dots. So if you have an even number of values, you're going to use some values that are not part of the data. All right? So let's plot those. So our minimum is still 7. Our first quartile is 25. Our median, quartile 3. And then our max. Our interquartile range is Q3 minus Q1. So we've got 47 minus 30, 25, which is 22. So that's just how spread apart the box is. So our minimum's at 7. And try to put your graph above the number line so you can still read the number line. 25. 36.5, that one is hard, but you just do your best. Third quartile, 47, and 59. Once again, if you could not tell where the dots are, you are welcome to write the numbers above your dots. So, if you kind of compare the 2 graphs, you can start doing some analysis and you just see like, oh, 25% of these data are that far apart and 25% of that data is only 1 apart. So that kind of means more of your data is together as opposed to down here. So there's a lot of analysis that can be done with these.